Hey everybody, good to be here. A real quick intro on me and my background. I'm a senior solutions architect manager. I lead a team of solution architects at NVIDIA. The team that I'm part of really covers down on the federal ecosystem, the public sector. That's across everything from civilian agencies like Postal Service and IRS to DoD and the intelligence community. And I've got one of my colleagues here as well. Mr. Rob Zupert is on. He leads our team, manages the team that covers down on the intelligence space. And please feel free to put questions in the chat. And I'm sure Rob will be able to answer many of them. And then maybe when we get to the end, I'm happy to, he can take note of those for us and call out any key ones I haven't answered, and I'm happy to take questions. Perhaps at the end is a little easier given the format here with the webinar format. So I think that's all I've got for a high-level intro. I've been here with NVIDIA, by the way, about coming up on 9 years. Rob and I have both been here about that long. So I will jump into the presentation as soon as I can get on the right screen. And are you seeing the slides change there, Seth?
Yes, all good.
Okay, great. So I'm going to just a quick little intro on human language technologies and conversational AI, particularly from the NVIDIA perspective. Then I'll go over some tools that software tools that NVIDIA has for these areas. And in particular, they're called Riva and Nemo. And then I'll talk about a couple of example use cases. Along the way, I'm going to try to play a few videos, maybe do a demo or two as well. So we'll see how it all works there. So quick overview here, human language technologies, HLT, everybody has different acronyms they use for a lot of the technologies in this area. In the spaces where I work, you'll hear a lot of people talk about HLT, maybe even more than NLP, but of course NLP I think is more broadly recognized, just across the globe. I tend to bucket these things into three sort of categories, if you will, being automatic speech recognition, natural language processing proper, and text-to-speech. And so under ASR, I tend to use that as like a higher level category. And under that, I put a few different things such as actual speech to text, right? But before you even get to speech to text, you might need to do things like just detect whether there's even voice in an audio recording. You may need to figure out what language is being spoken. Maybe once you know those things, then you can feed it into a speech to text and get some text out. Of course, once you have the text, you can start doing NLP. You might want to do things like named entity recognition or understanding tasks, or even question and answering, summarization. A lot of good things that I'm sure everybody here is familiar with. And then, of course, these days, more and more, we're wanting to interact with technologies, whether it's our phone or our cars or whatever it is. And we actually want it to speak back to us and maybe even sort of follow along in the conversation. And that gets into text to speech. Making speech from text that once we've queried some database, queried a language model, we have an answer back. How do we synthesize that back? How do we make it sound more emotive? How do we perhaps even make it sound like us or a person we're trying to represent? So conversational AI, I want to talk about this just a little bit because I do think it's maybe a word that I hear thrown about a lot at NVIDIA. I think it's sort of a little higher, more demanding, a little higher level, more demanding use case than simply, either, a pure ASR or a pure NLP type of use case. So the idea with conversational AI is that it's truly conversational versus just transactional. So when you think a lot of the current kind of voice assistants today, they're very transactional. They have a keyword, you say, okay, device, and then it wakes up, and then you say, can you call or take a text message or whatever, and then it verifies you want to do that, and then you do it, and then that's it. And then if you wake it up again, it's a completely new interaction. It doesn't remember what happened before, stuff like that. So conversational AI is all about having a language-based AI that can replicate human understanding a little more closely, including, the shared context from previous interactions as well as the current situation you're in. So if you say, things close to here, it should know where here is. If you're in your car and maybe you have a colleague sitting next to you, maybe, NVIDIA has a demo like this. I won't show that one today, but maybe you want the AI to kind of know that you're speaking to it versus your colleague if you're actually like, stare a second or two at the dashboard, but otherwise, if you say, hey, what do you want to do for lunch? If you're not looking at sort of the console area, then the AI knows it should just shut up and you're talking to your colleague, things like that. And also, of course, being able to have a conversation where it you ask it something, and a few minutes later, you're like, oh, and what about this? And it remembers that, before you were talking about Chinese food or whatever, right? So that's the kind of thing. Of course, it's also important, the conversational AI be very interactive. And so the responses have to be very quick. That's obviously where GPUs come in, being able to process these increasingly complex language models and get you a response. We typically find, whether you're doing this on a local device or you're going back to the cloud for your processing, we typically find that responses need to be delivered in 300 milliseconds or less. And just to reduce glitches, because I will want to play some videos and demos later, I'm going to go ahead and stop my video, Seth, from this point out. But that's just to make it easier and reduce any chance for glitches later. So that's what we mean when we talk about conversational AI. Probably everybody here gets that. And so this is a sort of a challenging task, right? This is conversational AI with a search task layered on. And so, for example, suppose you're somebody, you're looking at a catalog on your computer, and you say, what are some different types of lighting for a living room? Well, in a conversational AI, you'd have quite a variety of different, tasks that get broken down here to do that, right? You're going to have audio that's going to have to get, decoded, and you're going to have some language model. You're probably going to be running a variety of different natural language processing tasks, entity recognition, autocorrection, recommendation, querying, searching, these kind of things. You may also have a visual component in addition to the audio, right? I talked about before the example, the AI there may be a camera in the car looking at you, right? So it knows when you're looking, it knows when you're looking at it and when it's supposed to respond. In this case, there may be a system that knows, what your mouse is hovering on or what you've clicked on. So it knows, hey, what are some different types of lighting for a living room? It knows what web page you're on, kind of what's, more data to help it, get the right response. Of course, then you'll have to do a search and you'll have to come up with an answer and then synthesize that to speech and then maybe make it more emotive, maybe come up with a new web page and all of that. You get back hopefully in less than 300 milliseconds, something like, ambient task and accent is the answer. And maybe it points you to a web page or a list of web pages. And this is the kind of thing that NVIDIA is doing for a lot of our consumer internet company clients today and cloud provider clients today. We're helping them implement exactly these kind of things. And typically it takes 20 to 30 different models and containers strung together end to end. And you end up with, recurrent neural networks and transformer networks and convolutional networks and running at different levels of precision. But you need all that to happen in less than 300 milliseconds. One of the other challenges, of course, in this area is that most recently, these transformer models have really started to dominate, and they're really, really large. And we've seen that people are using these large, today, people often talk about things like GPT-3. It has 175, billion parameters. If you were going to train that on just 8 GPUs from scratch, it would take 36 years. If you use 500 GPUs, it takes 7 months. Now, those are 2-year-old GPUs, right? So on the latest GPUs, now we have Ampere, everything is faster. But in order to make these things go fast, you have to use a variety of different types of parallelism, something called data parallelism, probably people are familiar with. Scheduling and pipelining, people are probably familiar with a little bit. And of course, tensor parallelism as well, which allows you to break the different essentially layers of the network over different GPUs or processing unit. You can see this chart here scales up to thousands of GPUs and models that have 1 trillion parameters. And it's really these transformer models. If we focus just a bit here on the center chart here of this slide, that have really taken off over the last few years. They're really driving this. You know, a lot of people will credit sort of, just zooming out for just a second, sort of the renaissance in artificial intelligence and all the neural network work that has really taken off back to around the 2012 timeframe, when some grad students in Toronto made, took a neural network and ported it to a GPU, right? That was for the large scale image recognition competition, ImageNet, as it's called, which is I think today kind of viewed as a solved problem, because it's, they've gotten to better than human accuracy, quite a bit better than human accuracy on that, over a handful of years once they started using the convolutional neural networks and so on. And that's represented by this blue line here. And you had the convnets and the recurrent neural networks and so on. But then transformers entered the picture, which is that green line in the center. And what this is showing, of course, is the amount of compute, the training petaflops. So the number of operations in order to train one of these neural networks to a high degree of accuracy. And it's showing, the year that the network, was first published here, it came out on the scene. So what you see is that these transformer neural networks have really, they are designed, of course, from the inception to be more parallelizable, right? And they are designed to do more work for you than even sort of the original convnets, right? So transformer neural networks, I view them as sort of a deep learning 2.0, right? They kind of double down on some of the basic aspects of deep learning. You specify even less about the architecture of the network. You encode more into the data up front. You use fully connected layers, not convolutional layers, and the network should figure out the pattern of connections. And so, of course, all of that is more compute intensive, but also more parallelizable, which makes them a good fit for GPUs. And NVIDIA tries to track all the AI papers that are published around the world. And according to those folks at NVIDIA that track all these papers, 70% of them in the last few years have been discussing or citing transformer models. So it's really quite a change. So I'll talk about hardware here just for this part. I'm not going to really talk about GPUs too much, be more about software and things like this throughout this talk, but I'll just talk about GPUs and hardware here for this one bit. So NVIDIA just launched our latest GPU architecture. We come out with a new architecture of GPUs every couple of years. You might be familiar with that from like the CPU world, right? Every couple of years come out the new architecture, and hopefully it's bigger, better, faster, and all that. So on the CPU world, things haven't been getting faster. That's the whole end of Moore's law thing. But in the GPU world, things get quite a bit faster with every generation still. And so we came out with our latest generation in the beginning of this year, and that's called Ampere. And Ampere is a really dramatic step forward from our previous generations. And Ampere has something in it called the transformer engine, which as you might expect, is designed to specifically accelerate transformer models. And so the transformer engine, I like to think of it a bit more as a transmission, not an engine. But basically what it's doing is when you use the right APIs, you use one of the main deep learning toolkits like a MXNet or a TensorFlow or a PyTorch, something like that, and you're running transformer models with those, then the hardware automatically understands that you're running a transformer model, and it will look at the statistics of the math that's happening while you're running the model and the output that is due to the next layer. And whenever it can, it will drop down to a reduced precision. So, if you go from 32-bit to 16-bit, you can get twice as many operations per second. If you go down to 8-bit, you can get 4 times as many, right? And so it can be quite a significant speed up. So I think of it sort of as a transmission. It'll only do this in cases where it can deliver the speed up without any accuracy loss. And NVIDIA has been doing this stuff now for over 10 years. We think we're pretty good at it. It is something you can disable. You don't have to use it if you're concerned about that. but it can provide quite a bit of speed up. So this kind of hardware acceleration for particular types of neural networks like transformers, which are relevant in this space, is the kind of thing that NVIDIA has been doing in hardware for a number of years. But I think that's all I'm going to talk about in the hardware space. And what I'll say at this point, I'm going to go a little deeper onto this, but for this point, I just want to say that there's an end-to-end AI software stack that NVIDIA has for doing all the kind of topics that I just talked about, whether it's ASR, image classification, recommender systems, or speech synthesis. And not only do we have pre-trained models out there that you can pull down and download, all that stuff is free. A lot of this stuff is open source. But we have tools for doing, just basic ETL and data prep. That's our Rapids ecosystem. We have tools for supporting training at scale, whether you're a person who likes to get in there and turn the wrenches with a PyTorch or a TensorFlow, or you're looking for something maybe a little closer to a low code or no code environment. We have tools for that. I'll talk about one of those later. And then we have a whole bunch of tools around once you have a trained model that you believe meets the requirements and the accuracy that you need. How do I optimize that for inference, right? I want to set this up as a service somewhere, and I want to be able to have it run on a GPU, but one that's designed for inference and doing models as quickly as possible, right? So I can get that 300 millisecond turnaround for inference, and hopefully as efficiently as possible, and hopefully it's a smaller, lower power GPU that doesn't cost me as much, whether I'm doing that on-prem or in the cloud. And so on. So we have a whole bunch of tools for all that stuff and how you run all those containers and deploy a GPU driver in a container with Kubernetes, and you can build all this stuff up, build the whole stack up with things like tools like Kubernetes that we would use at scale. Okay. So I'm going to pause here and just play a demo of conversational AI. Hopefully move this here, and then I'll make this full screen. This is going to be our CEO, Jensen Huang. You can see him there. And I'm going to play this demo. He's going to be talking to a little mini avatar of himself. That avatar is created in a 3D virtual world tool that we have called Omniverse. But he's going to be speaking to it, asking you questions. It's going to be interacting with him in real time. This happened during our latest keynote earlier this year. However, again, while I'm playing a video, the actual demo, that was all real time. And so this, that whole conversational AI pipeline that I talked about earlier, from decoding his voice to understanding the question, to doing a query, to resynthesizing a voice that sounds like Jensen and all that, that was all happening live. I'm going to play a video of that now, but that was, so hopefully this will come across. We'll see how, and if for some reason this doesn't play well, Seth, just let me know. But this is short. It'll be like roughly a minute or so. This isn't many minutes.
Let me welcome back Toy Jensen, an application we built with Omniverse Avatar. Remember, Toy Jensen is not recorded. He's completely real-time, making eye contact, making conversation, and fully animated. Hey, TJ. I got a few questions for you.
Sure, ask me anything.
What is synthetic biology?
Synthetic biology is about designing biological systems at multiple levels, from individual molecules up to whole cells and even multicellular assemblies like tissues and organs to perform specific functions. It is also known as symbio, which stands for synthetic life.
Can you give me some examples?
Some current uses of synthetic biology involve creating biofuels, engineering bacteria with useful properties not found in naturally occurring organisms, developing biosensors capable of detecting environmental toxins, producing biopharmaceuticals, and manufacturing chemicals via fermentation rather than petrochemicals.
What are its medical applications?
Synthetic biology has many medical applications. For example, synthetic biology is being used to develop new vaccines, new antibiotics, and new treatments for cancer.
TJ, that was great. Can you tell us how you were made?
Avatar is a framework built on the Omniverse platform. It lets you quickly build and deploy avatars like me for a while.
Okay, I'm gonna stop there. We don't need to go into all the virtual world stuff, which is of course cool, but for another talk. So I hope that gives everybody a flavor for yeah, conversational AI and kind of some of the state of the art of what's possible there. So I want to dig a little bit more now into the NVIDIA tools for building the kind of stuff that we just saw there. So the first thing I want to call out is something called NVIDIA NeMo. This is an open source package. There's a bunch of pre-trained models for doing NLP, for doing voice recognition and speech synthesis, all those things we talked about are in there. And NVIDIA NeMo is, it's built on top of PyTorch Lightning. So people are familiar with PyTorch. PyTorch Lightning is kind of that meta layer on top of it that tries to make PyTorch even simpler, even more abstract, even more high level, a little easier to use. And NeMo is built on top of that. So it is for people who like to get in and know Python and can turn some wrenches and stuff. But it's for people a little closer to the data science side. But I think that you'll find that it has pretty easy to use set of APIs. We have 8 models in there right now for automated speech recognition, 5 different models for natural language understanding. Has quite a bit of deep learning based speech and language models that come with it. This will scale from 1 GPU on your desktop or your laptop up to thousands of GPUs. We think that the tools I'll be talking about today, NeMo and the other one Riva in a moment, you may see that our tools are perhaps don't have as many languages as coverage in terms of what they cover, in terms of some of the offerings from other folks that are putting language tools out there. We typically cover on the order of half a dozen to a dozen languages, something like that. But what you'll see is that you get a lot more flexibility with these tools. The ability to go in if you want to change, just fine tune just the language model or just the decoder, things like this. You can do that. You'll get a level of ability to go in and turn wrenches and do fine tuning that you don't get, say, with tools available from the cloud providers and things like that. And then of course it works. It works on prem. It works in the cloud on any cloud provider. You can just download the containers. You can run it. So it's kind of agnostic in that way. In particular, NeMo is open source. These are a variety of the models that are included in NeMo. We think that the models that we're putting out there are, again, they're all free. All this stuff that I'm gonna show you today. NeMo is completely free. Riva basically is free unless you start trying to use it to do really large quantities of stuff. Then it'll say you need an enterprise license. But you can actually use Riva for probably like a lot of academic purposes and things like that. You won't ever bump into that. So both of these are free. NeMo's open source. Riva's not open source, though. It's free up until a point when that threshold is set intentionally pretty high. So we're just trying to get the larger companies and governments, if they do really large stuff, then they have to pay enterprise license. You can see we've got really good scores here on Sacreblue and word error rates and so on, whether it's ASR, NLP, or even text to speech. Riva is the other toolkit I want to mention. NeMo is a little bit more for those that like working in Python and with things like PyTorch and PyTorch Lightning. Riva is a bit closer to your low code, no code type of experience. And so Riva allows you to do a lot of those same things. It works with something we call the Tau toolkit at NVIDIA, which is kind of this meta level low code, no code GUI that we have, an interface that we have, but Riva is part of that. And it'll let you go in there and build workflows around ASR or natural language understanding and text to speech and so on. And you can, again, there's a bunch of pre-trained models that come with Riva. I'll say that actually the Riva models are a little bit more slightly better performance than even the NeMo ones I showed on the last slide. And there's actually a reason for that. Because Riva is not open source, because it does have that enterprise tier, and what NVIDIA will do is NVIDIA will go out and, probably many folks are familiar with like the Libra speech data set and these various data sets that are out there. Some of them are open, you can go download them. Some of them, you have to pay University of Pennsylvania $50,000 or whatever to get it, right? And then there's more restrictive, redistribution and so on. So NVIDIA will go out and subscribe to all of these. The models that are distributed with NeMo, the open source tools we have for NLP, those models are all based on all the open data sets. Whereas Riva, because it's not open source and it does have a paid tier, there we're basically allowed to use all the training data sets that we had to pay for and subscribe to, even if we're not allowed to sort of, redistribute them and things like that, right? So we can get it. Riva models were actually able to squeeze out a little more accuracy. NeMo's probably good enough for almost everybody, but if you're looking to get, hey, I want that, the absolute best that NVIDIA can do, that's actually, you'll find that in Riva versus NeMo. Unfortunately, Riva is not open source, but again, hopefully that explains kind of why we have those two different solutions there. We do real-time language translation. These languages here, this is showing English to German, Spanish, French, Russian. We also have in Mandarin, we also have the other way. So we have Mandarin to English, vice versa. Late 2021, we actually won the WMT 21 conference. We got a score there of 77.5 on Russian to English news machine translation. It was the highest submission. So again, we think while we maybe don't cover as many languages as some other tools, the advantages to using the NVIDIA tools are that they're free, open source in the case of NeMo, extremely accurate. We think, the most accurate on the market. And they also let you go in and turn the wrenches and fine tune things at a finer level of granularity than what most other tools will give you today. So here, I'm going to do another demo, and let me pull my browser window back down. So this is a demo of Riva, actually, and this is just on our website. If you just go to developernvidia.com.riva, you'll be able to do this. So there's a little button here. You can upload a WAV file. It has to be less than 30 seconds. And then you can also just click on this and transcribe some audio. So I'm just going to read this paragraph up above here that describes Riva. So I'm going to click transcribe and read that, and then hopefully you'll see this just transcribing my voice to text here in real time. As speech-based applications are adopted globally, solutions need to interact with humans across many languages. Speech artificial intelligence applications need to understand industry-specific jargon and respond naturally in real time. Riva includes world-class automatic speech recognition and text-to-speech that runs in real time. So hopefully that translated pretty well. Speech-based or adopted. Looks like it maybe dropped a word or so. I think it's pretty good. So it is interesting. In the federal space, I actually, and you can see here languages, right? You can drop down. You can do like Spanish to English or German or Russian to Russian and so on. I actually have heard of cases of some folks in our armed services that will hit this web page while they're out in the field, and they'll actually use this to understand what's going on and get a transcription of a voice clip or something else. So So yeah, you can use this. So let me put that away. Back down here. And so all the things that I just described, those software, Riva, Nemo, all those pre-trained models, scripts that show you how to put those things together, those are all available in something we call NGC. So it's just ngc.nvidia.com. You can go there. Again, that's a free sign up if you already have an NVIDIA developer account. I think it's one and the same. Once you sign up for one, it's good for get you all into all the different NVIDIA sites. And then you can, we have, dozens, maybe hundreds of different containers there. They're all Docker containers. They'll also work under Singularity, and you can just pull those down and start experimenting with Nemo and Riva. And yeah, and then again, all the pre-trained models are there, as well as sort of demo scripts that show you how to get up and get going and so on. So quite a bit of helpful resources. Again, all that stuff is free. Okay, so I just want to talk a little bit about a couple of few use cases, examples to kind of wind up here. These are things that NVIDIA has been involved in some cases, folks on the team that I lead have been involved in. So I saw Kensho as one of the sponsors, and they actually presented at our GTC conference. Every spring we have our GPU technology conference, and that's a great place to go. You can go there. Again, it's free to register, and then you get access to all the sessions from prior years. So you could go there and type in NLP or ASR, and you could see what all the prior sessions were. But at any rate, they're part of S&P Global, and they were what they want to do is basically be able to take business calls. So when a company like NVIDIA has a conference call, at the end of the quarter, and the CEOs and the chief financial officer are talking about the results of the quarter and this and that, and why they're going to do better or why they might not or whatever, all that stuff. They have S&P records all those calls. And then they want to be able to obviously get text and accurate text transcription out of that. They found that their error rate was unacceptable given the many tens of thousands of hours of these that they have. And so they decided they would roll their own. Basically, they did this using Nemo. So they used our Nemo toolkit that we've talked about. They used a V100 GPU, if people are interested what the GPU was. And they were able to get a 20% improvement on their existing error rate, as well as dramatically improve the throughput. So the speed at which they're able to transcribe those audio recordings. And so much higher accuracy and much faster, and really worked out very well for Kensho and the S&P. And again, this isn't customer sensitive. They presented this result at our GTC conference. I think it was either this year or 2 years ago. So this is an internal tool. We call it Prospero. This is a little bit more of text analytics or text summarization tool. The goal, so Prospero is a tool created by some data scientists internal to NVIDIA. One of them is Chris Milroy, used to actually work on my team. Now he works on an adjacent team. The goal of this is to automate discovery of relevant assets within a large corpus of text data. So it's based on microservices, built from free software, can run on-prem or in the cloud, scales to billions of documents pretty easily. It's based on an NLP model called SentenceBERT, and then using similarity search. So the way this, the use case a little more in detail is this. I talked about our GTC conference that we have every year. We have thousands of presentations that happen there every year. And so the idea is, for someone who's new to GTC and really just trying to find their way around, how do they know which sessions they should go to or which things might be relevant to them? So they can go there and just go to this Prospero tool. Right now it's internal. We're going to be unveiling this for the world soon. So you all are getting a sneak peek here. but they can go there and just type in, some phrases, and then it'll pull up, for instance, all the GTC talks that are relevant to that phrase. So I want to do another demo here, and this is all based on these BERT models, which are really quite amazing. So let's see, here's Prospero. So this is Prospero, NVIDIA.com, but you won't be able to get to this unless you work in NVIDIA, you're on the NVIDIA internal LAN. But I'm just going to type in something like this, USPS. So that's all I'm going to type in, right? USPS, it's an acronym. I'm not telling the system what that acronym means. You and I know what it means, but this is just using a generic language model. It's been trained on, right? Basically, all the Wikipedia and all the freely available text on the internet. But that's enough for it to know what USPS is, as you'll see. I'm going to click generate here, and boom, if I jump down to like GTC sessions, you'll see it's giving a session on accelerated vehicle routing algorithms. So that would be exactly something, right, that the Postal Service would be interested in, right? So not only does it know, right, what USPS means, it understands that means, U.S. Postal Service, but it also knows then the kind of things that the Postal Service is doing or might be interesting, right? So the sessions it recommends are vehicle routing algorithms, optimizing warehouse logistics operations, and there's another vehicle routing thing. It also, gives some recommended courses here, getting started with universal scene description for 3D workflows, transformer, natural language processing. Let's see, what else is it recommended here? Past GTC sessions, shipping container tracking, reimagined with deep learning, right? Vehicle routing, personalization, discovery at Postmates. So all this from just typing in the acronym. It understands what that is and what the relevant, sessions are. We can do this perhaps with something like IRS. See here. And then we'll get preventing fraud, waste in public sector agencies, right? Makes perfect sense. The future of AI in government. So yeah, past sessions, accelerating AI in the federal government, solving mission-oriented challenges in federal government. So, just from typing in, IRS, no other context. So pretty impressive. And really, the magic of these transformer models is that they will, and obviously we can put in something much longer here, but you can put in longer phrases, of course. You could put in a whole, you could cut and paste, say a LinkedIn profile, right? So if there's somebody you're interested in, you could cut and paste their LinkedIn profile here, plop it in here, and see what it recommends. So pretty interesting capabilities, all made possible by these state-of-the-art language models. So there's Prospero. There's some architecture diagrams. Last use case I'll mention has to do more with the speech to text side. KALDI is a well-known framework for doing automated speech recognition. This was created back in 2009 up at the Johns Hopkins Applied Physics Laboratory. It's really considered a state-of-the-art ASR framework. In fact, that first example, the Ken Show group at S&P Global, they were using KALDI as their framework. But there's a variety of steps from taking raw audio and turning it into an actual sentence, so you have the raw audio and you do something called feature extraction. Then there's an acoustic model, ultimately a language model. And so there's different KALDI components that represent each one of these things. It turns out that on the inference side, once you've got a trained acoustic model and you've got your feature extractors and all that trained up, the long pole in the tent on inference is this decoder part, which is basically you have to do sort of a graph search to try to figure out what are the probabilities that the words you've seen happened in a particular order and so on, and generate, the most likely sentence from the sequence of words and weights for those words that you got from the feature extraction, the acoustic model. And that's, as it turns out, a very computationally intensive task. When our federal customer came to us with this task, they were measuring the ability to decode, that is to get a transcription of recorded audio in something they called real-time factor. So real-time factor is, how many times faster than real-time are you at doing that? So that is to say, if I have an hour's worth of audio and it takes me an hour to transcribe that, get an accurate transcription, then that's a 1-to-1, RTF. If I can do it twice as fast, then that's an RTF of 2. And they thought, right at that time, back when we started working with them around 2017, that an RTF of 2 at that time they thought was pretty good. We were able to move this decoder part to the GPU and dramatically accelerate that, basically get up to a 4100x real time. That's using a GPU which is now a couple of years old, so not even the latest generation. So thousands of times speed up, and basically we got to a point where you can do you can record 24 hours of audio, can be transcribed in under a minute. Just to show, what can be done with GPU acceleration in this area. And I think that's all I have, Seth. I hope all those little demos and videos came through well. Happy to look at the chat and see if there's any questions.
You have a couple of questions in the chat, and you have a couple of questions in the Q&A, and then I have one person who has raised hand. If people would like to ask a question live, use the raise hand feature, and I will enable you to ask your question live. Go ahead, Larry.
Yep, so let's see, I'm just looking now. I think this is the Q&A. It says, can your, with respect to the 300 milliseconds figure, what's the source for that? Has there been any work done on whether a quick response like, let me think, buy you some time? Yeah, that's a great question. That's something that comes out of our conversational AI team that does the work with our consumer internet companies and the folks that are building these bots and so on. Internal number, as far as I know. I'm sure there are tricks you can play, but the ideal situation is just to have the answer obviously on first try and get that back within 300 milliseconds. Can your pre-trained models be fine-tuned in terms of users' data? Absolutely. You can fine-tune them for jargon for your specific area. Maybe you're in the medical or military fields and you have jargon you want to fine-tune for that. Maybe you have very noisy environments. You want to be able to fine-tune for that. And we're able to help with that as well. But absolutely, that is the exact kind of thing that Riva and Nemo will allow you to do. That a lot of it's that kind of fine tuning, the ability to do it, is built into the APIs and into those toolkits, Riva and Nemo. Whereas we think it's not so much in a lot of the other traditional tools available, from cloud providers and other providers today.
I mean to cut you off. If you're done, let's take a question from Ansgar Sharp. Ansgar, are you there? No. Oh, okay. That's a missed call. So Larry, you can take another question.
Sure. I'm just opening up the chat now. Let's see. I see two. I'm probably going to go backwards, reverse order. It's just a little easy. Let's see. Looks like maybe my colleague Rob answered some of it. I would like to ask two hardware-related questions. Are Ampere's transformer specific functions available throughout the entire product line? Does NVIDIA's light hash rate technology affect AI applications? So the transformer engine is available through the entire product line is the short answer. I'm not, you say RTX 3060, I have to actually caveat that. So the GPUs I've all been talking about today are what we call our enterprise class GPUs. And so some of those other GPUs, our consumer class GPUs may not support them. RTX should be an enterprise class GPUs, should be supported there. Does NVIDIA's light hat range technology affect AI applications? Not as far as I know. That's something put in there for crypto purposes only. Let's see. Looks like we have maybe a question.
Let's take a question live from Sandeep Reddy, and after that, I'll call on Shekhar Pradhan. Sandeep.
Oh, thank you. So I was wondering, like, yes, transformers are good for NLP, but I have also seen some articles related to how transformers can be used for time series forecasting. So is it only just good to apply? Are transformers only good to apply, or are the results really good using transformers for time series forecasting?
Yes, transformers are very good for time series forecasting as well. People are using them, transformers, for computer vision applications now. They're literally taking over all the different fields of AI. Just to give an example, it's a related example to NLP, but at NVIDIA, we actually view cybersecurity as a data science problem, and in particular, a lot of it as an NLP problem. And so one of the things you can do is start to automatically, with the help of the processing power of GPUs, is you can process logs at large scale. And so you can do processing of cyber logs, which again, think of it as domain-specific jargon. So you take a more general, AI language model, train it on cyber data, and then you've got something that understands, what an IP address is, what a MAC address is, and so on. And then we use these models. We have a use case we call HAMA, which stands for human as machine, machine as human. And we basically train two transformer models for each for two different things. One is to simply understand the sequence of operations that someone's doing and the kind of things that they normally do. And the other is actually for the timing aspect. How fast are they doing it? And so the idea is to characterize every computer on an enterprise network as either a server, something that's basically an automated machine, or it's a laptop or a desktop. It's something that has a person operating it. And then once you make that characterization, if you see it start to act in the other way, then that's probably a red flag from a cyber perspective.
Awesome. Thank you so much.
Let's take a live question from Shekhar Pradhan.
All right. Am I on? Right.
Yes.
So at my company, where we use SBERT and bioencoders and cross encoders and so on, we use AWS's the Neuro Silicon that they've developed recently. I was wondering, how does NVIDIA's Ampere compare to that in terms of performance?
Yeah, great question. I don't have a slide or a direct comparison here at my fingertips for you. What I would do, though, is point you to something called MLPerf. So if you just Google MLPerf, or maybe Google NVIDIA MLPerf, there's a very, all the cloud providers are part of it, or I believe almost all of them. Many of the big companies are part of it as well. And
Perf,
that
right?
MLPerf. Yep, I'll just put that here.
Yeah.
Yep, and there you'll see, all the different companies that make different tools, and for both training and for inference for different models, and on their hardware, and you can get a pretty good comparison. Usually NVIDIA is the fastest or near the fastest on the MLPerf. The other thing I would ask you to look at too is look at how many, there's many different categories, whether you're looking at training or you're looking at inference. You'll see that there's many different categories, even within NLP or speech, right? All those different tasks we talked about. So there's a lot of different sort of sub challenges or tests inside ML Perf. You'll see that NVIDIA applies to all of them, or almost all of them. And so oftentimes folks will say, oh, well, I'm faster than NVIDIA on this particular one thing. And you say, okay, well, what about these other 4 tasks? And they didn't even submit a result. So at any rate, just a couple things to look for, but I encourage you to look at ML Perf. That'll have our latest publicly reproducible benchmark data.
Thank you.
More live questions. Did you cover everything in Q&A? Need to look back at that.
I think at the time I did. Is there another one now? Oh, yes, I see one. Yeah, you mentioned remembering context and nuance. Yeah, great question. I'm sure there is such a thing as too much remembering. It all depends on the context of the particular application you're trying to build. And so, maybe in a car, you wanted to remember just every time you turn the car on, but don't, once I turn the car off, forget, or maybe you don't. It's really, I think it's a really interesting question. And to me, it just goes to show that I think we're in still the early days of this AI renaissance, if you will, whether it's NLP or other areas. And I think we have so much more, we're going to see so much more AI seeping into everybody's day-to-day lives and how we interact with, cars and phones and planes and buy things and all of that. And it's already a lot. And I think we're actually still just at the beginning, and you'll see more and more of these fine-grained questions and applications like this.
Stephen, I had a follow-up. Is there anything less funky than the paradigm of slots in NLU?
Yeah, I guess I'm not sure what he's asking with that question. So I don't know if anybody else wants to jump in on that.
Any voice enable, Stephen. You should be able to go ahead.
Hi, can you guys hear me?
Yes.
Sure, yeah. Yeah, thanks very much for your talk. When we say remembering previous conversation, slot strikes me as really clunky. There's no sort of organizing or summarizing structure that I've seen. So like I say, if you ask, where did I travel recently, depending on the context of the question, maybe you're looking for an exact list of dates, flights, and flight times and airlines, or maybe you just want a general summary. Depending on how you remember it, it can sort of lean you towards one or other of those things, but I haven't seen much research on that. So when people say we remember previous conversations, it means we literally remember the text, but we don't have any sort of generalizing capacity or learning or inference. Would you comment on that?
No, I actually don't think I will. We've got a whole team. So I'm representing a little bit of work that, yeah, so, but be happy, to, Seth can make us an introduction afterwards. And if you've got a use case and you want to engage a bit more on that, and Seth, by the way, if you'd like to have a follow-up on this, happy to get, some of the folks from our conversational AI team. They may be a great presenter to go a little deeper on some of these as well.
You can definitely look at that. If you haven't, I can't recall, if you haven't shared your contact information and you want to do that, you could put that in the chat. For that matter, anyone who's participating today who wants to share a LinkedIn profile or link or anything like that, you can also do that in the chat. So Larry has put his email address in there. Do we have other questions for Larry or comments, either via the Q&A, you can enter them, or again, use the raise hand feature if you want to be voice enabled to ask your question live. Any other takers?
Yeah, I do see a Q&A here about Prospero. That one, I do know the answer. Does the returned information from Prospero come from publicly available web sources, or can you customize where your information is coming from? Yes, you can customize it. That's the whole reason d'etre for Prospero. So the way it works is I'll try to summarize it in a nutshell. You take one of these large language models, right? Like the sentence GPT model, and what will happen is when it reads in a paragraph or just an acronym or whatever, it's going to essentially create a number, actually a vector. Right at the top of that model, you'll have some 768 dimensional vector which represents the top layer output probabilities, right, of that input that model was fed. And so what you can do then, 768 dimensions, that's a lot to work with. And so what we do is we crunch that down, right? We use dimensionality reduction. We crunch that down to 3 dimensions, right? And so what you can do is you can run, like in this case, what we're trying to do is have a database that's searchable against all the GTC, GPU Technology Conference abstracts, right? The session abstracts. And so we'll run all of those through this model, get a number, right? Store that. And then, of course, project that into this 3-dimensional space. And you will, in fact, see, if you actually visualize that, you'll see that the talks on, NLP will kind of cluster in one part of the space, and the talks about computer vision cluster somewhere else, and the talks about signal processing, right, cluster together, right? So that all looks good. And then when you get a new query in, you run it against the same model. You get the number out, you put it through basically the same process, project it into the 3D space, and then you can just say, hey, what are the nearest, 3 talks or 10 talks, however many recommendations you want, to, my query in this space. So that's kind of, how it works. I'm making it sound simple. A lot of work there.
That's okay. So last chance, any other questions for Larry? Well, I'm not seeing any. I will, Adil has entered a question in the Q&A. You want to take a shot?
Yeah, the interfaces you demoed for text-to-speech, they contain explainability models that we can look at how the model reached that result, either through train, test, data, workflow. The short answer is I don't think so. I don't. Unfortunately, I think explainability is not built into most of the models we have on NGC today. And I guess I'm sorry to say that I think that that's the case with a lot of models right out there. And if you need that explainability, you need to be able to go in there and turn some wrenches. And if you're looking for particular things to be highlighted, hey, what are you keen on, model? Are you keen on the title? Are you keen on particular sentence in the input? You probably need to go and have some nodes in the model or some output nodes or whatever that will flag that for you. So I feel like explainability is a really important topic, by the way. It's how we build trust in our AI models. So I don't mean to give that short shrift, but I don't believe that's built into most of the models that we offer. And I think that's the case with most models that are out there. You have to sort of bring your own toolkit to do that yourself. But it's really important.
Okay, great. Trying once more. Any other questions for Larry? Not seeing any. We will wrap up. So thank you, Larry Brown from NVIDIA, for participating today. You entered your email address in the chat a moment ago in case anyone wants to get in touch with you. I'm going to reshare my screen here. So once again, the meetup video will be posted. It should be by tonight at the NLP XING YouTube channel. You can just go to bit.ly/NLP XING for this video, as well as videos of the previous programs that we've had online the last couple of years. And my email address is here. We'd welcome online talks, or if you are in Boston, New York, or Washington, DC, or can be, an in-person hybrid talk would be a possibility as well. That is, you would give an in-person talk and we would have remote participation via Zoom. So once again, thank you, Larry. Thank you to our sponsors, ARIA Basis Technology, John Snow Labs, and Kensho. And we do anticipate having a next program on August 4th. That will be in Somerville, Massachusetts, courtesy of Basis Technology. Once we get that together, it will be posted to the various meetup sites, and we hope that you'll be able to join us then. So thanks everyone for joining us today.
Thanks, Seth. Take care.